Okay, so I want to talk about the task system that we're using inside of Unity. Now, the task system is custom code that we built, and it allows us to execute actions as a unit or as a building or any other object in the game that has some kind of events that it can do or trigger or respond to. So the tasks basically controls what something is doing. All right, so let's take a look at that. If I go over to the actual code of a game, let me go and just stop it and restart it. I'm going to click on one of the drones, which I've selected this drone down here. You can't really tell because it doesn't highlight unless I click it. But this one represents this one, which I could actually show from this scene, so I'll just do that. Okay, so over here we can see that inside of this drone, it has a tasks script. Now, the tasks script has what is its unit info, which is effectively just the unit object right there. That tells it about what unit type it is. And then we also have a method or a task for it to start out with. So in this case, patrol 2 points. And then finally we have an active task, which will just tell us what task that it's doing right now. And at present, that's null. So when I turn this on, it's effectively going to take patrol 2 points and set it as the active task. But that task immediately spawns a bunch of other tasks. So we probably won't even see that show up in there unless we happen to catch it at exactly the right frame on this recording. And honestly, this recording might not work as fast as Unity is producing its frames. So I'm going to turn it on. All right, so it stepped through a few things really quickly, and now it's doing go to point. It got there and it did a pickup animation. Now it's going to point 2. Go to point 2. And here's point 2. It's this other rock over here that I marked out. It did a pickup animation, and now it's going to point 1. And I'm going to let it go here, but watch this. When it gets to the rock, it's going to say pickup animation. Pickup animation. And that lasts for 0.7 seconds. It's also started a move animation, but that we didn't even see it happen. All right, so let's take a look at what's actually going on with this. If I click onto patrol 2 points, that highlighted this item up here. If I look at the structure of where this is, you can see assets, RTS21, data, AI, and then there it is. Technically, this should be called tasks, not AI. All right, and I'll probably change that. But we have these 2 patrol points, or these 2 patrol points that we're going in between, and this is a list of the commands that make it, a list of the tasks, the individual's tasks that happen. So let's take a look at them. The first one is that it triggers a move animation. It tells the animator to start playing its move animation. Now it does this on repeat. So let's go to the move animation. When I see this, it says, okay, start the move animation, and it's going to look for an animator that's attached or a child of the actual unit that is taking this command. So in this case, it finds the animator and it calls the move command, and it lasts for 0.001 seconds. Now that doesn't mean that it's only going to trigger the move animation for that duration of time. It just says how long should the task wait before it assumes it's done with this animation, because animations are timed. So in this one, it goes off and then immediately finishes the task. This is basically a way of saying it's done right away. Okay, now I can also go to pickup animation, which is another one that it was doing, and I can see in this one it lasts 0.7 seconds, and that's effectively just telling it wait on this task for 0.7 seconds, which happens to match the amount of time it takes for the pickup to finish, the pickup animation to complete, 7 seconds. If it were some decimal of that, or 0.7 seconds. If it were some more finite amount, then I could do like 0.723 or whatever it might turn out to be. Okay, so we trigger that one, and another one that's in here is go to point 1 and go to point 2, which are basically the exact same thing except at different locations, and it's just telling its navigator where to go. Now this one doesn't have an exit time because it doesn't need one. This one has a safe range and basically says once I'm close enough to this point, once my unit is close enough to that point, then I'll say that the task is completed. Okay. Now let's go into some of the actual code for this. So if I jump into the Unity side and I go into the tasks code, inside of the tasks code, I can see that it has a linked list of tasks. A linked list because I'll want to be able to interrupt the current task and inject new ones. I'll want to be able to replace existing ones. And one of the fastest ways to be able to have an array that you can change the size and insert things into is going to be a linked list. Okay, so over here we've got our list of tasks, our linked list of tasks, and then we have what we were starting with and what's the active task. These are really, like, active task doesn't even need to be there at all. We technically don't need anything to track that. We can just trigger it and be happy, but it's there for debugging purposes right now. Same thing with start with. We only use that when we are first starting our code. Once we've done that, we never touch the start with again. Okay, and there's also no update command in here. We're using a coroutine on this command called task executor, which is basically what's executing the task for us. And it executes it. It says, okay, if you have a first value, if you already have something in your tasks, or if you don't have a task in there already, then we're just going to repeat this. So the next frame, it will come back to this and it will check to see if there is a new task sitting in there waiting for it to execute. At those points, it continues to execute. Now, technically, I could just have this freeze this or end this task, end this coroutine, and have another Boolean value. Actually, I'll put that, I think I'm going to put that as a task to clean it up later. Anyway, but effectively, if we don't have a first task in here, then it's not going to execute anything. It just waits until a frame where it does have something. Otherwise, it says, hey, our current active task, it equals the first task. And then we're going to remove the first one from the list. And then we will execute that active task. So once we have executed the task, we'll yield return it. So now Unity is going to wait on that task to complete its job before it continues this loop. So let's take a look at a couple of those tasks, or how the task is defined at first. So it has an execution, which basically just says, hey, go do the things you're going to do. It has an interrupt, which basically says you've been stopped. So if there's something like a unit is picking up an item or holding a hose or something like that, that we have some dynamic code for that applies a hose from one point into another, they can drop that. Or if they're currently repairing something, they can exit the repair task so that the target unit stops getting repaired. And then it goes to do whatever it was interrupted to do. And then finally, it has a clone. Each one is responsible for handling its own clone operations. So that way we can make sure things like saving, it has all the data stored, that if anything changes about this structure, that it'll happen on the next iteration of its use. Okay, so we've got the basic task. Now, one of the tasks was for animate. Now, this is a pretty basic one. When it gets it, it's going to get the component in children, which is itself or any child of it, for an animator, and call play this animation. And then it says wait for this duration. Now I'm going to make one small change in here, and I'm going to say if this.duration equals 0, then yield return, what is this one? Instant task completed instantly. Yield return new task completed instantly. And then, well, yeah, that one's it. It just does it. So the other one should be an else statement. Else. And I just had you guys all sit in here for this one. Control X. Okay. So I just dealt with one particular state. There's a particular event in here for completed task completed instantly, where if that one ends up coming back, it will effectively just stop right away. It won't wait for another frame. It'll continue on to the next task right away. So it's a shortcut for exiting out of something. If if we tell it to start an animation and that animation time is set to 0, it will immediately move on to the next task, which is usually going to be the travel to location. Okay, so inside of here, we wait for seconds, the amount of time that it had, or we tell it that the task completed instantly. Okay, so that's all that our animate task does. This is our completed instantly. Everything in here, if anyone were to use this, it's going to throw an error. There's only one happy path for it, and that's that we return it and something captures it. Okay, so we have some other ones in here, like task loop. Task loop just takes a list of tasks, has the execution in there. So it goes through, when it finds these, it actually goes through and creates a loop of them. It creates a clone of each one of the items in the loop and attaches them to the parent tasks. So that original tasks list, the tasks that we had in there, is responsible for being able to operate this. But after it adds all those child items to it, it adds a clone of itself, which means, okay, it's going to copy that, it's going to get into the next one, and it adds itself so that when it finishes all of these tasks, it's going to call on this one to execute this specific task loop again, or at least a clone of it. And then finally it yields breaks. Okay. So we've exited this right away. Or we've executed this one for whatever this task is, which this was a task loop. We've called all the child tasks, then we call it self again, so it adds them all again. And then let's take a look. There's another one in here, travel to. So this one is pretty basic, where we have a target of where we're headed, and when we execute it, we are getting the nav mesh agent from that unit. We're setting its destination and its stopping distance, and we yield return when it's close enough. Now, I believe there is some kind of event or some other Boolean state that I can validate against, but I couldn't remember what it was, so I just wrote a small piece of code to check its distance. And I'm using the square magnitude, so I don't actually have to process out a square function. All right. And so that effectively is how this stuff works. It's just a series of tasks that get added to the tasks or injected into the tasks. Oh yeah, so just to make sure I covered that, the tasks class itself has a pen, so you can add stuff to the end. You can inject stuff at, which basically says, do it now. It's going to be putting it first. So does it go at the beginning? Does it go at the end? And then it has clear. So sometimes a unit will just stop what it's doing and just the tasks disappear. But that's effectively how we control tasks in this game and make units do stuff.